Starting with this question, given the points P and Q as listed, find the equation of the line containing those 2 points. So what do we need to do first? Given 2 points, we need to find something equivalent in a sense to slope, namely the direction vector. So what is that direction vector going to be? What's my change in x? From -2 to 4 is up 6. Change in y from 7 to 3 is down 4. And from 3 to 5 is up 2. So that's my direction vector. Using the preferred parametric form, we're going to say x equals y equals z equals. Now we'll start with p. So starting at -2, 7, 3. Then we're going to add the values for the direction vector because I want to get to q. Notice if I'm at 2, I need to add 6 to get to 4. So we're going to add plus 6t. Similarly, 7 minus 4t, and 3 plus 2t. Now, how do we check this? So we've got this equation of this line. We say for various values of t, what do I have for x, y, and z? X, y, z. If t is 0, x is -2, y is 7, and z is 3. That's point P. If t is 1, -2 plus 6 is 4. 7 minus 4 is 3. And 3 plus 2 is 5. And that is point Q. But please recognize there's an infinite number of points that we could be using to define this line. But given 2 points, we uniquely determine a line. Now I want to go from a line to a plane. So now I have points A, B, and C, and I want to find the equation of the plane containing those points. So how do we find the equation of a plane if I'm given points? How do I find the equation of that plane? Finding the normal vector to that plane is going to be a key idea. And how do we find that normal vector? We're going to do that by taking the cross product of vectors. So I need to have vectors in that plane. So a reasonable one to start with would be the vector that starts at A and ends at B. So from 2 to 4, the change in x is up 2. From 1 to -2, the change in y is down 3. And from 1 to -6 is down 7. So that is my vector AB. And I need another vector in that plane. If I have 2 linearly independent vectors and I take their cross product, that will give me the normal vector to the plane. So what is vector AC, for example? That would be another vector in the plane. From 2 to -1 is down 3. From 1 to 3 is up 2. And from 1 to 4 is up 3. So the normal vector, if I have 2 vectors in a plane, let's think of this as AB, let's think of this as AC. The normal vector will be the cross product of AB with AC. And if I get the normal vector, then I can get the equation of that plane. So the normal vector N can be determined by taking the cross product of AB with AC. So let's take a look at that. How is that going to work? We're going to go I, J, K across the top. These are all vectors. AB, 2, -3, -7. And AC, -3, 2, 3. And we want to take the cross product of those 2 vectors. So how is that going to work? It's going to be the normal vector N, goes plus minus plus across the top, plus I times his minor, minus J times his minor, plus K times his minor. How do we find the minors? We cross out the row that I is in, and then we cross out the column that I is in. And we are left with -3, -7, 2, 3. We do the same thing with J, cross out the row that J is in, cross out the column that J is in. 2, -7, -3, 3. And then with K, cross out the row that K is in, the column that it's in. 2, -3, -3, 2. So what do we get? What will that normal vector be? So continuing with the computation, -3 times -3, -9, minus 2 times -7, -14, minus J times 2 times 3 is 6, minus -3 times -7 is 21, plus K times 2 times 2 is 4, minus -3 times -3 is 9. So what is this going to give us then? What do we see? -9 minus -14 is, of course, the same thing as -9 plus 14, or 5i. 6 minus 21 is -15 times -1 would be plus 15j. And then 4 minus 9 minus 5k. So any multiple of this will be a normal vector. So one possibility for the normal vector is 5, 15, -5. But if I have a large normal vector, if I cut it down to size, it still will be a normal vector. So let's go ahead and say we would prefer to use 1/5 of the normal vector as our normal vector. 1/5 of 5 is 1, 1/5 of 15 is 3, 1/5 of -5 is -1. So this is a normal vector for the plane. So let's go ahead and use that now as our new normal vector. I'll just put a little hat on it. So this is the normal vector we're going to use, which is 1, 3, -1. So what will the equation of the plane be? Will be 1x plus 3y minus 1z will equal something. And we need to determine what that something is going to be. So how do we determine what that something is going to be? How do we determine what number is going to go here sitting with that normal vector? If you recall, we were given these points, 2, 1, 1, 4, -2, -6, -1, 3, 4. So how can we use those points to figure out what number is going to go in there with that normal vector? Well, we just plug them in. So plug in a 2 for x, a 1 for y, and a 1 for z, and what will happen there? So you'll notice what we have. We have 1x plus 3y minus 1z equals something. I'm going to plug a 2 in for x, a 1 in for y, and a 1 in for z. What will that give me? 1 times 2 is 2, plus 3 times 1 is 3, minus 1. 3 plus 2 is 5, 5 minus 1 is 4. So the number that goes on the right-hand side is 4. That will be the equation of our plane. So the next question I want to ask is, what is the point of intersection of this plane and the line that we had earlier? The line we had earlier was x equals -2 plus 6t, y equals 7 minus 4t, and z equals 3 plus 2t. So think about that for a second. How would you find the intersection of this line and that plane? It's possible the line and the plane could be parallel and they won't intersect, but I believe in this case they do. So how could we find the intersection of that line and that plane? How is that process going to work? Well, it just comes down to solving for t. So what I have here is, again, I have x plus 3y minus 1z equals 4. And I have x equals -2 plus 6t, y equals 7 minus 4t, and z equals 3 plus 2t. I'm going to plug these in for those variables. So instead of x, I'm going to write -2 plus 6t plus 3 times y is 7 minus 4t minus 1 times z is 3 plus 2t. Notice I have x plus 3y minus 1z. That's got to equal 4. And that's just a matter of going ahead and solving for t. So what do we get here? We get -2 plus 6t plus 21 minus 12t minus 3 minus 2t equals 4. I'm going to make a quick check to make sure I didn't make an error. Minus 12t minus 3 minus 2t. That looks pretty good. 6t minus 12t minus 2t. What is that going to be? 6 minus 12 minus 2 is -8t. Then we have -2 plus 21 minus 3, which is plus 16, equals 4. Let's subtract 16 from both sides. Now we have -8t equals -12. Divide both sides by -8. And what does that give us? 12 divided by 8 is 1.5. 1.5. 3/2. So if I plug 1.5 in for these, I should find the point of intersection. So let's see if that is the case. So what do we have here? We have x is -2 plus 6t. Y is 7 minus 4t. And z is 3 plus 2t. Plugging in 1.5, that'll give me x is -2 plus 6 times 1.5. Y is 7 minus 4 times 1.5. Z is 3 plus 2 times 1.5. What is that going to give me? -2 plus 6 times 1.5 gives me 7. 7 minus 4 times 1.5 gives me 1. 3 plus 2 times 1.5 gives me 6. So we believe the point 716, which is certainly on the line, is the point of intersection of that line and that plane. So just one more thing to check. What was the equation of the plane? The plane was x plus 3y minus 1z equals 4. Do I get 4 when I plug those values in? Plug in a 7 for x. 7 plus 3 times 1 minus 1 times 6. Does that equal 4? 7 plus 3 minus 6. Does that equal 4? 10 minus 6. 4 equals 4. Yes, it is. So it certainly appears the point of intersection of the line we started with and the plane we started with was 7, 1, 6.